Good morning, guys. I am asking for your 103 from last class, so if I don't have it yet, please try to get that sorted by the end of Minute of Silence for me. And Hayden, it's not here. Okay, I guess no minute of silence today. So if I don't have your 103 yet, please bring that to me with your name on it in the next minute or two. I'm going to put the homework basket right over here. So as I've been saying, we are almost out of new topics. In fact, we really have two big topics, and the second one is really an extension of today's. So in a lot of ways, the stuff we're going to talk about in a lot of ways, the thing that we're doing today is kind of the last big hurdle as far as new material for us. So our agenda here looks like it has a lot of stuff, but I have you jumping around a little bit at the beginning. So one of the handouts you picked up is 104. So we're going to do the front page of that to talk about something called the DISC method. Then we are going to put that aside for a few minutes and give you a little bit of time to try that in Khan Academy. And once it looks like most everybody's finished with that, we'll move on. And to move on, we'll do the back of 104, which is going to be over the washer method, which is really just the DISC method with subtraction. So DISC method is extra important. And then once we do that, I've got one Khan Academy on that I'd like you to attempt. And then you also picked up the circuit on the way in. We will not get very far on the circuit. I just would like you to start it, but it's over these topics. So this is a B week. I will see you again tomorrow. And a big part of tomorrow's class will be working on the circuit. So the more you can get to that and get a chunk of it done today, then that would just make that much easier in class tomorrow. Okay, so 104, the front page here. So this is very similar to what we did last class. It's just that the three-dimensional shapes are being kind of created in a different way. So last class we talked about adding an infinite number of two-dimensional areas that makes a three-dimensional shape. They were either perpendicular to the x-axis or perpendicular to the y-axis. So when you stack up those two-dimensional shapes, you get a three-dimensional shape. But overall, the answer-getting thing that you have to memorize is that you were integrating area. Well, we're going to be doing the same thing today. We're going to be integrating area formulas, but specifically circle area formulas. So DISC and washer method, we're going to be integrating pi r squared. So these are also very hard to draw, so I have some pictures here to help you kind of visualize this. But if we take a two-dimensional area, we can rotate that around the x or y axis. And so if you imagine this two-dimensional area spinning three-dimensionally, and everywhere it goes, it creates something three-dimension, that's what this would look like. So this kind of shows off a little cross-section, but basically you could take any point on here, imagine it's rotating around the x-axis, and you can see that you get a bunch of circles, and because it's a bunch of circles, that's why we are going to be integrating pi r squared. Okay, so down here I have a little bit of a typo here, but it doesn't take a million questions for you to kind of see how this works. So I'm going to do one where I rotate it around the x-axis, give you a minute to try it also, see how much of it you can pick up. Then I'm going to do one where we rotate it around the y-axis, and then give you a chance to try it before we go over it. And then we'll sidebar to Khan Academy for 10 or 15 minutes. So, okay, so all of these questions will either give you a graph or there'll be something reasonably easy to graph. So let's sketch y equals 0, and y equals x squared minus 3. So all of these questions, there's going to be an area that's trapped under those functions. So just like up here, there was this area that was trapped that I highlighted. That area is what's spinning around the x or y axis. So in this question 1, this is what I'm trying to spin. Now, you don't have to do this, but I think it's a good habit to get in. Your AP exam doesn't expect you to do it, but mathematically, if you're going to rotate something around the x-axis, a lot of the times we do like this little arrow here to show that we're spinning it around this line and not that line or whatever. So it kind of helps you see. Okay, so notice if I took some points, like maybe these 2 points, I'm just picking 2 random points. If I rotate these around the x-axis, you need to see that we're getting circles, and I'm only sketching in 2 of them, but to get a 3-dimensional shape, I need to have an infinite number of circles. And where the infinite comes from is integration. Integration makes sure that we have an infinite number of these things. And just like last class, we integrated area. Today we're integrating area. It's just that the area is going to be pi r squared. Now the parts that are nice and consistent is because we're rotating it around the x-axis, it's going to be dx. The bounds should be x values, and our radius needs to be in terms of x. Not in terms of r, not in terms of y, but in terms of x. So sometimes your picture is good enough, bless you, to see how far left and how far right this enclosed area is. This is a good example of one that's not. So if you don't know exactly where this is and exactly where this is for the bounds, you can just set these equations equal to each other. And then you can figure out it's at negative square root of 3 and positive square root of 3. Now, also like last class, when we integrated area, the part I tried to get you to slow down and put extra thought into was the base lengths, because the base lengths were sometimes y, occasionally 2y, even sometimes they're half of a y, but usually they were y. Same thing here, except we need to be extra careful with the radius length. Addison, you need to put your phone up. So if you sketch in a couple of these, you can visualize the radius length. It's the distance from the x-axis to the function, distance from the x-axis to the function. The generic name for that is y. So the radius is y, but again, you need these variables to match. If this says dx, you need this to be in terms of x. So don't call it y, call it x squared minus 3. So also like last class, I'm not going to ask you to integrate any of these by hand. I'm fine with you using a calculator. We're focused on setting them up. We can practice the integrating by hand another day. Okay, so I would like you, I'm probably not going to give you time to finish, but I'd like you to try this question too. So I sketched a picture, I sketched in a couple circle cross sections to see the radius, and then try to integrate pi r squared and see how close you can get in just a minute or two. And again, I don't mind that you guys are getting up and getting a calculator, but I'm not even expecting you to throw this in the calculator yet. I just want to see that you can set up the integral correctly. So, calculator's not going to do much for us until we get to the Khan Academy, maybe. So that may not have been enough time, but that's okay, because hopefully you at least slowed down somewhere. So if the trickiest, well, there's some parts of this that are just super quick. So you're going to be disk and washer method. You're going to be integrating pi r squared. If it's revolving around the x-axis, it's going to be dx, and most of your integrals already set up. The only things left from our work here is we need to figure from what to what and what would the radius lengths be. So you probably need a picture for that. So the equations I give to you should trap an area, so you need to realize where that area is. And if you're rotating it around the x-axis, this point would rotate about that far, this point would rotate about that far. Nothing fancy, but I can see that this radius length is the distance from the x-axis to the function, also known as y. This radius length is from the x-axis to the function, also known as y. So the radius length in this question is y, but you need these variables to match, so call it negative x squared plus 4 instead. Okay, now if you sketched a better picture than me, you already know the bounds. My picture is pretty sad, but I can also just set the equations equal to each other, and after a second I can see that it was negative 2 and positive 2. So again, we're just creating a bunch of an infinite number of two-dimensional circles, and the way that we are adding up an infinite number of circles is integration. That's why it becomes a calculus thing. Okay, honestly, I think you could probably make some pretty good guesses. Oh, I'm sorry, this is also a typo. This front page is all about the disk method, not the washer method. The back page is on the washer method. Okay, so let me show you the difference if we rotated it around the y-axis. So I would still recommend that you sketch a picture. X equals 0, y equals 0. And y equals negative x plus 8. Y-intercept of 8, slope of negative 1. So there's going to be an area that's trapped. But this time we're going to try to spin it around the y-axis. So again, you don't have to do these little circle arrow things, but they kind of help you remember what you're doing. You're still going to be integrating pi r squared. The differences is if you're rotating it around the y-axis, you need a dy. You need the bounds to be y values, not x values. So this one you would get lucky because they're the same. X is 0 to 8, but y is also 0 to 8. But make sure you're paying attention to the y values if you're rotating it around the y stuff. And you need your radius to be in length in terms of y. Not in terms of r, not in terms of x, in terms of y. These variables need to match. So what's going to happen is if you don't try to sketch a picture, you don't have this to look at, trying to figure out what would the radius length be here, I think is almost impossible, especially for the first time of you seeing this. But if you have the picture, you can take a point that's the furthest away from the line you're rotating it around, show that point rotating, take another point that's as far away from the axis you're rotating it around, rotate it around, let yourself see a couple of these cross sections. Let yourself see a couple of the circles it would create. Because then you can see this radius, and what do we usually call the distance from the y-axis to the function?
X.
Right, the generic name is x. So r is x, but we need x in terms of y. So you're going to have to take this equation and solve him for y. X is the same thing as negative y plus 8. So again, pi r squared every single time, dx, x values, dy, y values, but you need to force yourself to be extra careful. Use your picture. You need to put eyes on your radius before you start making a guess about what you think the radius is. So I want to give you one more with quick feedback. So if you would please try just question 4 for a minute or two. See how close you can go.
There might be places where I need to add more to some of those things, but just let me know if you think I do.
Okay. I'll try to scan it in a second. You don't have somewhere else you need to go?
No.
Okay. Remember how quiet your pre-cal class used to be?
Oh my gosh, it's terrible.
That's this class. Okay. Again, I realize that may not have been enough time, but I'm
Trying to help you see that some parts of this is quick and easy and some parts take a little bit more thought and you have to slow down. So when you move over to the Khan Academy in a second and just practice the disc method, we're going to come back and talk about the washer method after that. They will either provide a picture for you or these equations are going to be easy to work with. X equals 0, y equals 0, and x minus 5. All of those are pretty easy to graph. Okay, we are rotating this around the y-axis. So the integral that I need to set up, I know is going to be pi r squared dy. I can see the y values go from -5 to 0. And the only thing that's taken me more than about 10 seconds to get the answer is the radius lengths. So if I'm rotating it around the y-axis, take a point the furthest away from the y-axis. So any of these points are fine, but just pick one, rotate it around the y-axis so that you can see its circle. Pick another point, rotate it around the y-axis so that you can see its circle. The point of that is so that you can see the radius, see that the radius in this question is x, and of course you wouldn't leave this x because this is dy, but it tells you that you need to know what x is in terms of y, and x is the same thing as y plus 5. Okay, do you guys get pretty close on that? Okay, again, it's fine if you didn't, but try to learn from your mistake. If you tried to do it with no picture and that held you back, then try to do it with a picture, please. Okay, I don't know that you will need much, if any, scratch paper, but if you do, please go ahead and call it 105. And you have 2 Khan Academies assigned to you. Make sure you're doing the right one. Only do the disc method for right now. again, once it looks like most everybody's finished, we'll jump back, do the back page, the washer method, and then you can do the washer method Khan Academy.
So I thought that this. Actually, I was supposed this was T's patient, so
Yeah.
I totally didn't.
Now that's, you don't have to change it here. You're right. It's just that most of the time in calculus, this isn't going to be a nice straight line. It's going to be something curvature, so then it's not going to be a cone. Yeah. It's just that I rigged some of these first questions to where they're quick to work with, so you'll see more like what they're like in the Khan Academy. But also, if you work them out both ways, you can see that you do get the same answer, so that's kind of nice. So while you guys are chipping away at this Khan Academy, up here I can just see the scores, so I can see like how many people have finished it. It also shows me which questions you've done and how many people have gotten a question right and wrong. So if there's a common mistake happening, I'll go ahead and address it on the board. And if there's not, I will just wait till about everybody's finished to move on. And again, feel free to use a calculator here. I don't care if you I don't care if you want to do it by hand, but that's not the point of these. The point of these is to make sure that we can set them up correctly.
Am I good to go?
Yeah.
of them though. Number 10. You need to make sure you look back at the difference, the limit comparison test, because that's different than just the comparison test. So make sure you look back and back up for that one. And then on 15, that's true, and the limit does need to be 0, but when I'm looking at your work, I'm not convinced this goes. Because if I multiply this, this looks like it would be an into the third in the top, and I think this would be an into the third. So that limit wouldn't be 0.
It will look like one.
It would, yeah, 1 or whatever the coefficients are, but you need it to be 0, so there's something off.
So
in there
it can
somewhere.
work.
It does need to equal 0,
Right.
and it does need to be decreasing, but I don't think this equals 0, so there's something wrong here or
Okay.
here somewhere.
Okay.
You need to look back at.
Okay.
And see, 1 or 2 of you are already finished. Again, you can just hang tight for a few minutes, let everybody else catch up. Or if you want to try one of the washer questions, you can, but I haven't told you how to do it yet, so don't put too much effort into it. Or you can maybe do 1 or 2 questions on the circuit, and that would be that much less you'd have to do tomorrow, because I will see you again tomorrow. Just a suggestion.
assuming that you're still talking about the limit all the way through. The limit of that of n approaches infinity would be 4/8 or a half.
Before the class.
Yeah. That's what I'm saying, if it's, let me check my system. So just, yeah, so that should be going to.
It's supposed to go to zero, right?
Right, well, if it converted it to this.
Which it said it does.
Yeah. Let me work it on my own, out to the side, so I can maybe figure it out that way.
Yep.
For number 10, I did the A sub n over B sub n.
Okay.
And then is 0 positive and finite?
Mm-hmm.
So the limit comparison test always will get me.
Yeah. I don't
Um,
practice that one very much. So. Let me pull up the notes because that'll make it quicker. I know it needs to be positive and finite. You need.
A sub n and B sub n both have to be.
Do you not do
greater.
those separately? I feel like you do those separately though.
On my notes it said the limit of A sub n over B sub n. Yeah.
Okay, so then. So A sub n is their question.
Mm-hmm.
B sub n is what you're comparing it to. So what
Right.
did you compare it to?
1 over n.
Okay. And well, okay, so first off, this doesn't go to 0. If you try to plug infinity in here, 1 over infinity is undefined.
Mm-hmm.
So you need to rewrite this a little bit first. You could multiply the top and the bottom by n.
And then it would be n sine 1 over n
Yeah, over 1.
over 1.
So, no, that wouldn't be finite though.
That would be infinity, wouldn't it?
Yeah, that would be infinity. Okay, I'll look at that one too.
Okay.
Sorry, just give me some time.
No worries.
Oh wait, is the answer that it? The answer is that it converges for that number 10.
Yeah. It's that it.
Okay, so the problem there then is it's.
It diverges, so it's
They,
not positive.
yeah, you picked 1 over n, which diverges. So if that had been a positive finite number, you would know that their question also diverges. So you need to compare it to something that converges.
Wait, but it says the answer is you compare it to 1 over. So, but that makes sense because I was trying to say that because it goes to, I felt like it went to 0, which is not positive finite, therefore it wouldn't converge. Right?
I don't know, maybe they consider positive. No, 0 is neither positive nor negative, that's what I thought.
So,
Okay, this is. Sorry, I was looking at number 10. What number was that on your 6?
no, it was 10 on mine.
What was the first one you asked about?
15.
15, okay. Looks like we've got about 7 people still trying to finish up, so
Okay, wait.
wait a couple more minutes.
For number 10, I feel like what we just said was correct, but we were thinking it was converging. Because we said that it goes to infinity, which is infinite, so it diverges. And the question, the correct answer says that it diverges.
Okay, if you feel good with that.
I do feel good with that.
Okay.
But then 15, I still don't.
So they looked at, I looked at their work to see if it was more efficient, and it wasn't really, but. So this is, I kind of understand what you're doing here. You're taking a term, dividing it by the previous term, and you're trying to see, we don't really need this to go to 0. We just need it to be less than 1, because that would tell you that the next term is closer to 0.
Okay.
But I think you can just do a comparison here, because if you flip this over,
Mhm.
this is 4n plus 4, and this one would be 4n.
Mhm.
So this one's bigger than that.
Oh.
Over here, this is n squared plus 2n plus 1 plus 9.
Which is bigger than that. So
Right.
you can just kind of.
Yeah,
Okay.
so you can compare those and realize that this one has to be bigger because its numerator's bigger and its denominator's smaller.
Okay.
So you can just try to say that in words.
Okay.
Now, the other thing that I do for those questions,
Mm.
this doesn't help when you have to show your work, but what was the, you remember what the series was, the original one?
This.
Okay, so this doesn't help if I'm trying to prove it, but if you just plug in the 1 here, you get 4 over 10, or 2/5, and then plug in 2, you get 8 over 13. And then if you plug in 3, you get 12 over 18, which is 6/9, which is 2/3. That doesn't sound right. Plug in 3 is 12. 9 plus 9 is 18. But okay, with the alternating too. So when this is 1, this is positive, then this one's negative, and then this one's positive.
Okay.
Anyway, sometimes you can just, if you can visualize, they're getting closer and closer and closer to 0. Then if you
Okay.
just need to know the answer and not show that that's happening.
With the test.
Yeah.
Okay.
I do that for a few terms. Now, that doesn't guarantee it's right, but if you do it for a few terms on any other choice you think has a possibility, then that can help you narrow it down a bit. Okay, I'm good with that. So I will update this in gradebook.
Thank you.
Yeah, just make sure that all that's fresh. No, you keep it.
Oh,
You
okay.
can keep it now.
Okay.
You might also scan the ones that you got right too, because I only made you do corrections on the ones you missed, but
Yeah.
you might have made educated guesses on some of the others, so. Okay, I'm gonna set a 2-minute timer and then we're gonna go on. Again, if you don't get it to 100 right now, that's fine. I just will ask you to try it again before tomorrow for your homework points. Of course, you can try it as many times as you need to, but.
we gonna have his mock exam?
I don't know if it will be required, but I will share a mock exam with you on AP Classroom.
Okay.
The problem with doing them on, we used to do them on Saturdays, but the problem with that is not everybody can go the day we pick, and then okay. Even if you're not finished here, go ahead and put that aside for a minute, and let me show you the back page of 104 so we can talk about the washer method instead of the disk method. And if you were listening to me at the start of class, it's really the same thing with subtraction. So it's really the same logic that we did with area between two curves. So let's go ahead and talk about those notes. And if you did not finish the disk Khan Academy, you might choose to do it before moving on to the washer one in a few minutes anyway. I'll leave that up to you. Okay, so the logic behind the washer method is the same logic that we did for area between two curves. So in January, we talked about if you want to know the area under a curve, that's when you got introduced to integration. And then right before spring break, or not right before spring break, but like a week before spring break, we said if you had, that's a terrible one. If you had another function that you could find his area to with integration, if you would like to know the area between those, you basically take the area of the bigger shape, or the bigger area, which would be all of this in red, and then you take away how much of it is not trapped between those two. So a lot of times we talked about this as top minus bottom, or right minus left. So we're going to be doing the same thing, but with volumes. We're going to find the volume of the big outside shape, and then we're going to take away the volume that we don't want to be part of our answer, and what will be left over is the volume that we need for our answer. So it's kind of like doing the disk method twice and throwing a subtract sign between them. Okay, so just like the front page, I'm going to do 2 of these for you as an example and give you a minute or 2 to try a couple of them before I go over them. Okay, so this time we're going to start with the y-axis. So graph y equals 0. X equals 1. And y equals 3x minus 9. Just like the disk method, there has to be a trapped area. Now, I will warn you that one of the harder parts about washer method is realizing it's washer and not disk. So I'm going to try to emphasize that as much as I can here. So please make sure you're trying to catch on to that, because that will be a big hurdle for you if you don't catch on to it. I'm going to rotate this area around the y-axis. And what's different about this compared to the disk method, if I go back up, notice on this disk method, this trapped area was all the way hugged up next to the axis I was rotating it around. All the way hugged up next to the axis I was rotating it around. Same whether it was x or y. The enclosed area was all the way pushed up to the axis we were rotating it around. This question, that's not true. I'm rotating it around the y-axis, so this gap in area is going to create a gap in volume when I rotate. So I'm still going to take a couple points on the outside and rotate them around this line. So I'm doing the disk method that you started on over there. And I'll do this one in red. So integrate pi r squared in terms of y. And I can see the y values go up to 0 pretty quickly. Down here, if my graph is, if you're careful, you'll see it's -6. But you could always just set those two equal to each other. When x equals 1, y equals -6. You can set these two equal to each other. Okay, and then the radius length, well, I shouldn't have done that. The picture is even more important, because here's the radius length.
that would be the center, to where it hits this point on the circle. So the distance from the y-axis to the function, the distance to the y-axis to this function is 3x minus 9. That generic name is x, and x is equal to 1/3 y plus 3. X is 1/3 y plus 3. Now, the problem is, that would be assuming that this was also had area there. So like we rotate this and we get one big three-dimensional shape. But what's going to happen here is there's some missing area. So I'm going to try to do this in purple to help you see that. So now, instead of taking points on the outside of the enclosed area and rotating them around, I'm going to take some of the points closest to the axis I'm rotating it around on this enclosed area. So if I sketch in those circles, you can see that when you rotate this in 3 dimensions, you actually got a cylinder missing out of this middle, kind of like this picture right here. There's a big 3-dimensional shape, but somebody took out the cylinder. So I guess you could subtract the volume of a cylinder if you knew that, but you can also just do calculus. Integrate pi r squared. The r's in all of these are just 1. And this is perfectly fine to write it like this, but you probably want to make a habit out of writing it this way. Since both of them have a pi, both of them are -6 to 0, both of them are dy. Well, 1 squared is just 1, so I'm not going to square it. You can combine that into one nicer looking interval. Again, technically these two things are equivalent. This is just not as scary looking. The other nice thing about this is these questions, the washer questions, always have this format. They will always be integrate pi big R squared minus little r squared. The big radius always needs to go first because it's giving you the full volume if nothing's missing, and then subtract the small radius, which is where you're subtracting the volume that's not really there. So again, if you kind of lean on this format, it's harder than this method because you've got to find 2 radiuses, but otherwise you're just subtracting them. Okay, so the next one is around the y-axis, so go ahead and try that and see how close you can get with just a minute or two.
let me cut you off here, finished or not. So I sketched this picture just a second ago, and without any context, I did it, and this enclosed area was so small it was going to be hard to work with. So I actually erased my picture, realized that what I cared about was going to be up here in quadrant 1. So obviously the bigger your picture is, the easier it is to see what you're working with. But you should have tried to rotate this around the y-axis. So I'm just going to do the condensed form. You should have written it as pi big R squared minus little r squared dy. Okay, I know this y value at the top is 9. This y value down here I think is 4. I need to be careful. It's when x is 2 and y is x squared, so that is 4. Okay, and just like the disk method, you need to be the most careful about the radius lengths. The big radius is going to come from taking points the furthest away from the axis you're rotating. So pick a point or two, sketch in those cross sections, see that the radius length is, the big radius length is x. And x is the same thing as the square root of y. I'm just solving this equation for y. Square root of y. Now, of course, as a multiple choice question, squaring the square root, they would probably just call this whole thing y. But okay, and then the little radius, so let me erase this to get this out of the way. The little radius is going to be when you take points nearest the axis you're rotating it around on the enclosed area. And it looks like no matter which one you pick, they all have a radius. It's not variable. It doesn't have a variable in it. Looks like that length is always 2. So this would be acceptable. Again, you don't have to condense it into one integral, but it's a little redundant to split it into 2. And again, I don't care that you change this, but as a multiple choice, realize 2 squared, they're probably going to write that as 4, and the square root of y squared, they're probably just going to call that y. But you could adjust that on the fly as needed to be. Okay, so I think you could probably make a pretty good guess about how the x-axis is going to work out, but let me say that for you one more time, let you try it, and then move on, and hopefully you guys won't have any homework. Okay, so again, I have no idea what this picture needs to look like, so I'm just going to dive into it. X equals 3, y equals -3, and then 3x minus 9. Something like this. Thanks. So, not a great picture, but I really only need this anyway, so I'm going to erase this stuff, make it a little easier to see. You've got to graph those lines so you can see the trapped area. If the area is not trapped between those equations, you didn't graph one of those equations correctly. Okay, now I'm going to rotate it around the x-axis, which is right here for me. So again, it's the same thing I just said, except I'm trying to do it around the x-axis. Now, to me, I can instantly see this is a washer method and not a disk method. And here's how I know that. Yeah.
Wouldn't the 3x minus 9 line intersect to the amount of x equals 3? Since it's at minus 9, it would intersect the x-axis at 3.
Yeah. Here's my x-axis up here.
Oh, I thought.
Yeah. When you sketch some of these, that's another reason why you might want to put the little arrow thing. It helps you remember where your x-axis is. This is not my x-axis. This is my x-axis. Okay, so again, one of the hardest things for people to see, how do I know if I need to do big R squared minus little r squared, or is it just this method? And if you have area next to the thing you're spinning it around that's not part of the enclosed area, like this gray stuff, When I spin this, this missing area is going to create missing volume. That's how I know this is a washer question. So I'm going to integrate big R squared minus little r squared dx because we're going around the x-axis, 2 to 3 because those are the x values we're interested in, and then the slow part. The big R is going to come from points rotated around that axis that are the furthest away from that axis. So all of these have a radius of 3. Big R in this question is just 3. And then the little radius, small r, is going to be the points on the enclosed area closest to the area that the line you're rotating it around, the missing stuff. And this one is the distance from the x-axis to the function. The distance from the x-axis to the function, the generic name for that is y, but I need it in terms of x. So don't call it y, call him 3x minus 9. Now, of course, we will be practicing some FRQs. I think you'll be surprised to see how often these things show up on FRQs, but they are usually pretty friendly as far as the setup. A lot of times, even if you just have it in the format big R squared minus little r squared, they tend to give you 1 point just from that. But all right, so quickly here, go ahead and do your best with the last one, and then hopefully I can help you catch some mistakes before you move on. I'm going to go ahead and sketch it, but I will wait till I think you're done. Okay, finished or not, let's see. So I went ahead and sketched the picture. One thing I want you to notice is this picture, I had more space. It's a much bigger picture, means it's easier to work with. Give yourself space. You need an extra sheet of paper for an assignment, it's going to be worth it. You should know the format is pi big R squared minus little r squared without even knowing anything about the question. Since we're rotating around the x-axis, I put dx already. And now if I look at the x values I'm interested in, it's 1 to 2. Shouldn't need any longer for that part. But be extra careful on the big radius. That would be the points furthest away from the axis you're rotating it around on the enclosed area. Each of those radius links are the x-axis to the function, x-axis to the function, which is what we call y, but we need to put that in terms of x. Y is equal to x squared. For your little r, you need to be taking points closest to the axis you're rotating it around in the enclosed area. Rotate a couple of those around, and you can see that no matter where you sketch those in, those all have a radius of 1. And then of course as multiple choice, x squared squared, they're just going to call x to the 4th. 1 squared, they're just going to call 1. So as a multiple choice, it's going to look like that. So I have one question for you. Okay, so not on multiple choice questions, but on free response questions, what do you think is the most forgotten part of this work when you do this on a free response? The pi. You guys get so focused on figuring out what the r is, or the r's plural, that you forget that you're doing circles, which is pi r squared. So that doesn't really happen to you on multiple choice because you see some of the choices have pi. You get a little bit of a hint. But try to phrase in your head. You're doing an infinite number of circles. That's why we keep drawing in these circle cross sections. Okay, so you guys have about almost 20 minutes here. So I would like you to do the second Khan Academy, please. Now, if you didn't finish the disc one, you're welcome to do it first, especially since the washer builds upon that. This is one of 2 things that you need to have done for me tomorrow. And some of you will have it done here in just a minute. But I also want to give you points for your 5 corrections from the second AP Classroom assignment that I gave to you. So again, that was, gosh, I don't know, over a month ago at this point, but I told you I would forewarn you. So you did several progress checks, but 2 of them were from Unit 2. Unit 2 A and B. So those focused on product rule, quotient rule, stuff from Unit 2. So, like last time, if you only missed 2 questions, I only expect to see 2 corrections. I'm looking up your score in AP Classroom. So if I can see you only missed 2, I'm only going to expect 2 corrections. If you missed 7 questions, that's okay. It was just a refresher, just a review. But you need to pick 5 of them to do corrections for.
Can you show the last one again?
Yeah. So, I know I verbalized that, but again, it's typed up on the agenda page. So if you forget, you can pull up the class website and make sure that you know what to bring to class tomorrow to make sure you get all the points.
Is Khan Academy graded on our work that we do, or how many we get right out of 4?
It'll be from that score. So again, we're not going to have class time to get to the circuit, at least not as a group, but that's a big part of what we're going to do on Friday. So if you guys have nothing going on during advisory, I know you don't want to work on the circuit, but if you did work on the circuit, it would make tomorrow a little easier. So it at least would be a good use of your time. Also, some of the circuit questions do get pretty difficult, so it's kind of nice to knock out the first few that are very similar to these notes that we just did. And just so you know, the other big topic, the last big thing that we need to do, there's a couple tiny things I need to show you. A couple little formulas I need to remind you of, like derivative of inverse tangent, the derivative of inverse sine. I've showed you those, but I've never really held you to it much. The only other topic is the exact same thing we did today, but instead of rotating it around the x or y axis, you rotate it around other lines. So instead of the x-axis, you might rotate it around y equals -1. So you're going to get the exact same radius, but it might be one bigger or one smaller because you're shifting the line you're rotating it around. So it's the same thought process, but the r's are even harder to find. So but we won't look at that till next week. So, alright, because you gotta have a picture or you're not gonna be able to see it. If you're rotating it around the x-axis, the big ones are gonna come, you're talking about the r's? Yeah. The big r's are gonna come from the points furthest away from that line. So if you take a couple of these are the big r's in this question. And each of those are the distance from the x-axis to the function, which is why I said y. But y is equal to x squared. You need these to match. And then the small ones, you need to take points closest to this line, draw in those circles, and then you can see each of those are just 1 in length. But trying to do that without a picture is going to be impossible. It's just too hard to guess what r is. Even with the picture, it's pretty hard sometimes. I know this doesn't mean too much to you now, but when we do start moving into doing more practice FRQs, when we can just focus on AP review, you're going to see that our 3 most recent topics are often make up one of the FRQs that we get. Oh, okay. Is that the Monday? Yeah. Okay. So that would be area between two curves is usually part of an FRQ. Volumes from known cross sections that we talked about last class, and then today's disc and washer method. So our 3 most recent topics are likely to be one of your 6 AP FRQs. So.
the last few pages, you need to set up the interface, just like the answer guide.
Oh, I thought the instructions said just a graph. So I erased it.
Yeah, it says the sketch them, but it didn't mean just sketch them, so I'll give you full points if you want to finish it, but.
Okay.
Okay, you guys still have about 8 minutes, so still too much time to quit here. But again, I think the only homework that some of you have is finishing up these Khan Academies. So if you don't get 100 on both of these, please do that before tomorrow. If you did not do the 2 progress checks from Unit 2 when I asked you to do them weeks ago, then I guess you need to do that also to get caught up. But hopefully if you didn't do them when I asked you to, you at least caught them up over spring break, because I don't intend for that to be extra homework, but it would not be fair to not give points to the people who did do it, so you've at least been warned.
Yeah, you're like, I hate when I do not. I go to live first.
I've seen this.
I want to just library.
Kind of just sucks that
That's why I'm with
Every time I do
If I join myself to Owl Creek, it's like 3 minutes away from my house. So it's not easier ever. I go to Life Source now, and it's like I just hope I never get Appleseed in the spring, because then I have to, I think it's like double couches.
What's your own?
Yeah, we do climbing, we just kind of like interact. This is something to do.
Is it a cloud?
Yeah, but I really like this one.
Building your back.
We just get to talk to maybe Jeff Tester and get the cover. Riley. Well, no, we get to lead like the second.
That's a nice room.
And the second thing.
That's like he's making my room for 2 people.
Jeez.
That actually.
Are you guys?
I'm telling you, I'm gonna do. I'm doing it next year again.
What?
Is it also?
It's really.
Yeah, we accidentally heard 2 doors down. It's not crazy.
What is your, what is it?
That makes sense.
I guess the bells are not on. I don't know. Time to go.